Unit 4.6, isosceles and equilateral triangles. If we know that it is an isosceles triangle, in other words, if we know two sides of a triangle are congruent, then the opposite angles are congruent. In this diagram, we know that AC is congruent to BC. Then we can conclude that angle A is congruent to angle B. The converse is also true. If two angles are congruent, then the opposite sides are congruent. So if we know two angles are congruent, then we can conclude that it is an isosceles triangle. So in this diagram, since angle 1 is congruent to angle 2, then we know that side DE is congruent to side FE. As we discussed before, if a triangle is equilateral, then it is also equiangular. And it can go either way. If we know it's equiangular, then we know it's equilateral. If it's equilateral, we know it's equiangular. So a triangle is equilateral if and only if it is equiangular. Angles of equilateral triangles, each of the angles have to be 60 degrees. So let's look at some problems and apply what we know. So we want to find the measure of angle R. So this is the measure we want to find right here. We know that PQ is congruent to QR. So that gives us an angle P is congruent to angle R. We know that one of the angles is 60 degrees. So if we subtract that one, and since this one's congruent to this one, we can divide it by 2, and we'll have what each angle is. So 120 divided by 2 gives us that R would be 60 degrees. So angle R, the measure of angle R is 60 degrees. Well, that tells us that all the angles are 60 degrees. And if all the angles are 60 degrees, we have an equilateral triangle. All angles equals 60 degrees, which gives us that is equiangular. Which gives us that it's equilateral. So that means all the sides would have to equal 5 centimeters. So the measure of PR would equal 5 centimeters. For the next one, we want to find the measure of each variable. We know that DF is congruent to FE. So that gives us that angle D is congruent to angle E. So D has to be congruent to E, but we see here that E is also congruent to F. So we have a triangle that is equal angular, which means that each angle would have to equal 60 degrees. So 4x minus 8 equals 60, 4x equals 68, and x would equal 17. These two sides are congruent, so we set them equal to each other. So 8y minus 5 equals 6y plus 3. Subtract the 6y, so 2y minus 5 equals 3. Add the 5. 2y equals 8, so y equals 4. For the next picture, we have that all sides are congruent, so we have equilateral, which means that all the angles are congruent. So each angle would have to equal 60 degrees. So 3x equals 60, and x equals 20. We know that all the sides are equal, so we'll pick this side here and this side, the two sides we have information for, set them equal to each other. So 2y minus 6 equals 8. So 2y equals 14, and y equals 7. Which statement correctly names two congruent angles in this picture? So the first one's asking us for PJM. So PJM would be this one right here, and PMJ. We don't have enough information to show that those two are equal. JMK would be this angle here, and JKM is this angle here. Well, if those two angles are congruent, it is because these two sides are congruent. Since JM is congruent to JK, we can say that these two angles are congruent to each other. For the next portion of this problem, which two statements correctly names two congruent segments? If I look at the last one here, PM and PK, I know that this angle is congruent to this angle, so this has to be congruent to this. And that concludes the lesson for 4-6.